Okay, let's talk about division now. Division is the undoing of multiplication. So if I ask you a question, hey, 172, let's say, divided by 2 is equal to what? That's the same thing as saying, hey, what number, when I multiply it by 2, will get me 172? That's the question that I am asking. Okay, and so what I'm going to start with is just how do we do division when it's nice and simple numbers like 2. Okay, there's some easy ways of doing division rather than resorting to long division, which I will be getting to because not every number is as nice as 2. Okay, but if you have a number like 2 and we're dividing, say, 172 by 2, some of you I'm sure have already got the answer, which is good. But let's get through this. What you can do is just go through the number, break it into pieces. So we're going to take this 172 and say, well, I could think of that as 170 and 2. Okay, and then what I can do is just divide each of those pieces into 2, or by 2, and then add them up. So 100 divided by 2, that's 50, and 70 divided by 2, well, half of 7 is 3.5, so half of 70 is 35, right? So half of 70 is 35, and then 2 divided by 2 is 1. Hopefully that's not a surprise for anyone. And then if we add all those up, I have 5 plus 1 is 6, and 5 plus 3 is 8. So the answer, 172 divided by 2, is equal to 86. Okay, now that works really well for 2 because 2 goes evenly into 10 and 10 is the base that we work in. What if instead I was to ask, okay, 100 and let's say 74 divided by 3. What is that? Okay, well, it's still asking the question, okay, I need to take a number and multiply it by 3 and get 174, and I'm going to try and do this the same way, but I need to be a little bit craftier. I need to come up with numbers that I know 3 goes into, that I can break up and try and get them so that they add up to 174. So let's see. What's the biggest number I know 3 goes into evenly? Well, one thing I could do, let's say 99. I know that 3 definitely goes into 99 because 3 goes into 9. So I could say, all right, 174 is equal to 99 plus, well, what's left over? So 174 minus 99 is, well, 4 minus 9, can't do it, gotta borrow. So 14 minus 9, that's 5. 6 minus 9, can't do it, gotta borrow. 16 minus 9 is 7. Okay, so 99 plus 75 is 174. So I could say, all right, so 174 divided by 3, that's the same as saying 99 divided by 3 and 75 divided by 3. And those numbers I can do pretty easily. 99 divided by 3 is just 33, and 75 divided by 3, for anyone who's worked with money, right, 3/4 is 75 cents, so this is just 25. So I can add those up to get my answer. So 3 plus 5 is 8, and 3 plus 2 is 5. And so what I have then is 174 divided by 3 is equal to 58. Now, what if you're not feeling so confident? Let's just check our work to make sure. Well, how do we check our work? Well, we can go back and say, hey, what is 58 times 3. It should be 174, but let's try it. 3 times 8 is 24, so that's 4, carry the 2. 3 times 5 is 15, plus 2 is 17. So that is 174 as expected. So there we go. We've just done some simple division. And so you can practice this with a few other examples. Right, and this is just so that we can do division quickly, and quickly and in our head, or at least quickly on a piece of paper without having to resort to long division. Sometimes we're going to have to, but we're going to just do a few more simple ones. What if I wanted to say take, I don't know, 100 and I don't know, let's say 96. 196, and I want to divide this by 4. Okay? What does that equal? Well, once again, I'm going to break this up into numbers that I know I can divide easily by 4. So I know that 4 times 4 is 16, so let's do 160. So I can say, hey, 196 is equal to 160 plus something. What is it? Well, 196 minus 160 is, well, 6 minus 0 is 6, 9 minus 6 is 3, and 1 minus 1 is 0. So 160 plus 36, right? So 196 divided by 4, that's the same as saying 160 divided by 4, and 36 divided by 4, and then just add those two numbers up. Okay, 160 divided by 4, I can do that, right? Because 4 times 4 is 16, so 160 divided by 4 is got to be, well, it's got to be 4 times 40 to get to 116, right? So this is going to be 40, right? And 36 divided by 4 is, well, okay, can we do that? If you're good, hopefully you recognize, hey, 4 times 9 is 36, so the answer here is going to be 9. Let's say that wasn't so easy, then we could break this down even further and say, hey, 36, we could say, okay, 36 is equal to 16 plus 20, right? All right, and we could say, well, 16 divided by 4, right, is 4. 20 divided by 4 is 5. 4 plus 5 is 9. So, as I said. So there we go. So we can do some fast division this way. Notice when I say fast division, I'm doing a lot of writing down here because I'm explaining it to you. These are things that you could do just chicken scratch. You do not have to show all of this on a test at all. If you can do it in your head, more power to you, okay? But if you're worried about making mistakes, okay, then writing a bit of chicken scratch somewhere, just your workings out, that's fine, okay? Remember, the test, we don't have a calculator, so you need to have some methods of doing these things and ideally doing them quickly. All right, so back to the question, 196 divided by 4, well, you just take these two numbers and add them together, we get 49, so 196 divided by 4 is equal to 49. Okay, let's check our work real quick just to make sure. Okay, once again, on a test, okay, I won't be marking whether or not you check your work. Okay, I won't mark whether you check your work. However, if you check your work, you'll know you're right and get more marks that way. So it's a good practice to get into. But let's do this real quick. 4 times 9 is, oh, well, hold on, this is a nines thing, so I can use my nines trick. I can put down 4, my fourth digit here, my fourth finger, and so it's 36. Okay, cool. So that's 6 there, and a 3 that carries, and then 4 times 4 is 16, plus 3 is 96. Notice, as we did that, I had 36 plus 160 kind of showed up as I was multiplying, and those were the numbers that showed up here. Isn't that interesting? There's probably something to that, isn't there? Anyway, so yeah, we can always take the numbers that we're dividing and break them down into smaller numbers that are easier to divide, and then add them back up to get our answer. In this case, it was 49. So there you go. There's hopefully a useful trick for division. Next up, long division. What happens when you don't see the useful tricks, or if there are no useful tricks? Okay, long division is how we can do division in the worst weather. Here we go. Okay, so that takes care of arithmetic. On to long division. Okay, so let's say that you're presented with the question 60,578 divided by 7. Okay, well, already I'm getting a bit of a headache because I don't know my 7 times tables very well. It's one of the least used times tables, right? So, okay, so already I'm thinking, okay, this is probably going to be something I should use long division for. So how do I do that? Well, I'm going to take the number I'm dividing by, and I'm going to write that down like so, and then put this sort of weird house thing, okay, is the symbols that have been used since time immemorial, or at least since around the Italian Renaissance or something. And then we're going to divide 60,578 by 7. Notice the order of the numbers has flipped. That confuses some people sometimes. So I sometimes hear students say, oh, this is 7 divided by this. No, it's the number that's in the house being divided by the number that's outside the house. Okay, so we're breaking this into 7 bits and seeing how big those bits are. Okay, so what long division does, okay, is kind of like what we did before. Long division is going to break up this big number into smaller numbers, but instead of just hand-picking numbers that are easy, instead it just decides to keep track of the remainders. So meaning the leftovers, the stuff that rather than just picking up the easy things, we can say, okay, the first thing I'm going to do is say, how many times does 7 go into 6? Oh, well, none, right? So, okay, so forget that. Let's now ask, how many times does 7 go into 60? Remember, what we're really asking is how many times does 7 go into 60,000, right? And then we'll keep track of what is left over from there. Okay. So 7 goes into 60. Well, let's think about this. I know that 60 is, let's see, 6 times 10. What is a factor of 7 that is in the 50s? Oh, I know that, let's see, does 7 go into 50? 50, oh, is it 56? Hold on, how do we do this? Okay, well, we're gonna take a guess. It's certainly not gonna be 10, right? That's too far. It's not gonna be 9. We could guess that 7 goes into 68 times, all right? And then we'll just figure out if we're right. What is 8 times 7? If it's lower than 60, then we're good. So so 7 times 8, well, I know that 8 times 8 is 64, subtract 1 8. I think I've done this one before, actually. So this ends up being 56, so cool. So 7 does go into 60 8 times. So 8 times 7 is 56. Oh, 56. And so there we go, 8 times 7 is 56. And now I'm gonna figure out, okay, with how much left over, right? So 7 goes into, so really what I'm saying is 7 goes into 60,000, 8,000 times with how much left over? Okay, well, 8 times 7 is 56. Subtracting that from 60, I have 4. So what I'm saying here is that 7 goes into 60,000 8,000 times with 4,000 left over. Okay, because we're just looking at thousands for the moment. Now, moving on. Now I want to talk about hundreds. So 4,500 could be thought of as 4,500, right? So I'm looking at 45. 7 goes into 45 how many times? Well, looking at this, 56 was 8 times 7, right? If I subtract 7 away from that, that would be 7 times 7, which would be 49. Okay, so that's too big. So 6 is going to be my guess. Let's check it. 6 times 7 is 42. Check my work just to be sure. Okay. So all right, so 6 times 7 is 42. 42 is less than 45, so we know that we guessed right. We got the right number there. 45 minus 42 is 3. Okay, so once again, we're keeping track of the remainders. So what we just said there is 4,500 minus 4,200 is 300, right? 7 goes into 4,500 600 times with 300 left over. So now we're going to switch from talking about hundreds to tens, so that we bring down the 7, and now we've got 37 tens. Okay, or, well, yeah, there's no good English way of saying it. It's 70 and 300, but yeah, so we just think of it as 37 tens, and I want to know, okay, how many 7s go into this 37, if we're looking at blocks of 10. So 7 goes into 37 how many times? Well, I know that 7 times 4 is 28. So 7 times, oh right, of course, because 7 times 5 is 35. So there we go. And so we have a remainder of 2. Yeah, 7 times 4 is 28. That's an important thing to remember. No, here we go. Right. And now, so that leaves 20 left over, right? 7 goes into 375 times if we're looking into blocks of 10, so 37 blocks of 10, 7 goes into 37 5 times. With 35 blocks of 10 is how many we get there, with 2 blocks of 10 left over. Cool. And now bring down the 8, and now we're finally looking at units. All right, and so we've got 28 units. 7 goes into 28 units. How many times? 4 times. 4 times 7 is in fact 28. And so we get our final remainder is 0. So what we have is 60,578 divided by 70 is in fact 8,654. Okay, and so there's your first example of long division. Okay, now let's try another division. I'm going to take 208,002 and divide it by 16. All right, and we're going to see what happens now. So the first question is, okay, 16 goes into, well, does it go into 2? No. What we're going to do is find, okay, what is the biggest group, the smallest group of digits that 16 does go into? And it goes into 20. It goes into 20 just fine. It goes into 20 once. Okay, cool. So then we multiply 1 times 16. So that is 16, right? And we find out, okay, what is the remainder of 16 going into 20? It is 4. Okay, cool. So now moving on to the next place value, we're going to look at 48. 16 goes into 48 how many times? Well, okay, I know that 16 is around 20. right? To multiply 20 to get to 48 would be, you'd multiply it by 2 and get 40, and that would be as close as you could get. So 16 is less than 20 though, so it's going to be either 2 or 3, right? So let's write down quickly 2 times 16, and what is that? 2 times 6 is 12, and 2 times 1 is 2, so 32. Okay, cool. If I say, okay, what's 16 times 3? Well, that's the same as just adding 16 to this. 2 times 6 is 8, and 3 to 48. Hey, look at that. Okay, so that means that 3 times 16 is exactly 48. Okay, cool. And so what we have then is a 0 here. Okay, this is good because it provides a good example. All right, now, so I'm going to bring down the next 0. And if we were to follow the algorithm exactly the same way that we've been doing it, I would have to say, okay, 16 goes into 0, 0 times, multiply that out, okay, but we don't need to do that. What I can say is, well, 16 goes into 0, 0 times, and then 0 times 16 is 0, but I don't have to write that part down because it's not going to change anything, right? Subtracting by 0 will keep it 0. So I can just bring down the next number, which is still 0. Oh, okay, so 16 goes into this bunch of zeros still 0 times. Okay, cool. And now 0 times 16 is 0 and all that, and so I need to bring down the next number, which is a 2. So now what I'm looking at is 16 goes into 2. How many times? Well, 16 goes into 2 exactly 0 times. With a remainder though, right? So now we have 0 times 16 is 0, which gives me a remainder of 2. So we could write that in our house notation here by just throwing an R2 at the end. Now, what does that mean? What that means is this. The answer to my question is 208,002 divided by 16 is equal to 13,000. And now what that remainder 2 is, that is 13,000, and that's the number of sixteenths, the fractional part that comes at the end. It's 2 divided by the number that we were dividing by, so 2 divided by 16. So it's 13,002 which we could then put into lowest terms. We haven't gotten to fractions yet, we will, but just for the sake of completion, that is of course 1/8. So that is what a remainder is. Okay, if something doesn't divide evenly into a number, all right, you'll end up with a remainder, and that remainder tells you the denominator of the fraction that is in your mixed number answer. There we go. Okay, let's try another one here. So we've got 712,775. And I'm dividing that by 35, okay? There's something that's gonna happen here that is one bit of a hiccup that could happen while you're doing long division, so I wanted to demonstrate that here. So let's try this. First, 35, does that go into 7? No, of course it doesn't. Does it go into 71? Yes, 35 times 2 is 70, so it goes into 71 twice. 2 times 35 is 70, and we have a remainder of 1. Okay, cool. Bring down the 2, and right here is the hiccup. Right, we're now asking the question, okay, 35 goes into 12, how many times? And it doesn't, and that can cause frustration for people, but then you have to remember that our friends in India in the 300 AD-ish era, they came up with a nice solution to this, which is to say, oh, it goes in 0 times, right? We have this nice symbol of 0 to say, oh, okay, it just doesn't go in. But then we can say, okay, so 0 times 35 is 0, but we don't have to write that. All we can do now is just bring down the next number, right? Because what would happen, if you like, you could try it. You could say 0 times 35 is 0, which will leave me with 12, and then I'm going to bring down the next number, so that would be 127. Or we could just skip all that and go straight to bringing down the next digit. So now I'm asking, okay, 35 goes into 127 how many times? Well, that's a harder question. I know that 35 times 2 is 70, so adding another 35 to that would be, well, 70 plus 30 is 100, so that would be 105. Okay, and 27 is not 35 more than 5, so 3 is my guess. So what did I say? So 3 times 35 is 105. Right, so now 127 minus 105, doing the subtraction, okay. 7 minus 5 is 2, 2 minus 0 is 2, 1 minus 1 is 0. Okay, so now we've got a 22 here, and I bring down the 7, and now I'm asking, okay, 227, how many times does 35 go into that? Well, let's see. I know that 35 times 3 is equal to 105. Okay, I know that 35 times 2 is equal to 70. So that means adding those all together, 35 times 5 is going to be 175. And is that close enough? Well, hang on, we can add another one. So 35 times 35 times 6 would be just add 35 to this. So that would be, well, 17 plus 30 is 200, so that's 205, but then plus 5, so that's 210, and that brings us within 35. So 6 is the answer that I'm looking for. 6 times 35 is 210. 7 minus 0 is 7. 2 minus 1 is 1. And 2 minus 2 is 0. Okay, and then bring down the 5 finally. So the 5 comes down here, right? And I've got 175. How many times does 35 go into that? Oh, look, in my list of factors over here, I had 175 already, so I know that 5 is my answer. 5 times 35 is 175, and in this case, there is no remainder. So, just to write down the answer all nice, I have 712,775 divided by 35 is equal to 20,365. There we go. Cool. So that is long division. I'm going to put up some rules of long division. I'll probably put them up here. I'll type them up on your screen. And we'll just list off what we've done in the algorithm. Okay. Yeah. So what we are going to be doing in class is taking up these 4 different operations and practicing doing them quickly and correctly. All right, and we've got long division covered. So that wraps up this lecture. Okay, tune in next time. We're going to start talking about fractions. So see you then.